Hey everyone! Thank you so much for watching another episode of the Weaviate podcast. I'm super excited to welcome Kyle Davis, the creator of RAGKit. We've had an awesome brainstorming session and we're about to just dive into everything retrieval augmented generation or RAG, explore all these topics and hopefully increase our understanding of them. Kyle, thank you so much for joining the podcast.
Yeah, thanks so much for having me. I'm excited to talk everything RAG. There's a ton of stuff happening in this space right now.
Amazing. Could we kick it off with the story of RAGKit, like the opportunity you saw and what motivated you to build it?
Yeah, for sure. Yeah. So I started RAGKit in January of this year. So it's a relatively new company. And I decided to build it based on my experience at a previous startup, actually. So last year, I was working at a startup doing AI workflow automation, which was a lot of fun. But one of the problems we faced was setting up RAG pipelines for our product. There's just like so many different relevant techniques and stuff is constantly changing in the space. You basically have to become an expert to maintain a high quality pipeline. So that's sort of where the idea of RAGKit came from, is setting up this sort of fully end-to-end developer platform and API that focuses on sort of solving that issue. And we're trying to make it easy for companies to build high quality RAG pipelines very quickly.
Amazing. So I think that's the first big topic we'll try to take down is the RAG pipeline, like ingest, query, tweak your index, evaluation. How are you currently seeing kind of what is a RAG pipeline? What are the key abstractions around it?
Yeah, so RAG at its core is like fundamentally a search problem, right? So you're working with a limited context window in these large language models, and you want to get movement to it. So commonly right now, vector databases are really popular, right? That's what Weaviate is, right? And you get these like embeddings and put information into a vector database, and that's really fast and really performant. It has like a lot of really nice qualities. That's why it almost seems synonymous with RAG, that people consider RAG to be a vector database. But we're starting to see like knowledge graphs and graph databases be more popular, and even things like keyword search and like your traditional search algorithms, those are all RAG too. And any combination of these for like getting stuff into your context window can be beneficial, right? And then another important part of RAG, I think, is the evaluation piece. Like you can't really improve what you can't measure. And I think this often gets overlooked a lot. So uh, a really good evaluation framework right now is Ragus. I think you've had them on the podcast previously, but we can talk more about that later. Um, but having a good framework like that, I think, is really important. So to summarize sort of like how we're building RAGKit, we have four pillars, right? You have an ingestion phase, a search phase, a response phase, and an evaluate phase. In the ingestion, that's sort of what we're talking about with vector databases and knowledge graphs. You get a document, chunk it, store it somewhere, and make it ready for fast retrieval. The search phase is when you go to your indexes or the internet, retrieve the data for the original prompt. Maybe there's some tool use in there, like using a calculator or whatever. You're just trying to find the right data. And then you have a response phase where you take the user prompt and generate a response. This is where you're going to do things like chain of thought prompting, or even just like determining if you need to do RAG, because not every query needs RAG, and then some will need like a back and forth. Like you do one query, then you might need more information because it wasn't enough, kind of thing. And then the evaluation phase is the fourth and final phase, using Ragus to sort of measure how everything's doing.
Yeah, so definitely a lot to take down. I guess I think maybe if we could just kind of take them down one by one and starting with the ingestion kind of phase. I'm so interested in this kind of like ETL for vector databases. You mentioned earlier knowledge graphs and keyword scoring like BM25, and probably a lot of Weaviate listeners will know that hybrid search is one of the big Weaviate features, and sort of having the vector index as well as like wand pruning on the BM25 keyword scoring, and sort of having these two things. And something that we're super excited about is maybe when we interviewed Andy Pavlo and studied his vision on the self-driving database, this was like, a really inspiring kind of direction. We've been thinking about like what is an AI native database, and maybe the database Weaviate evolves from just vector search to also maybe knowledge graphs, and having this kind of tuple index as a part of Weaviate, as well as more optimized kind of relational join structures and things like that. So I'm very curious about if we can maybe start with this kind of like ETL phase of preparing the data for the database to then kind of help with that search. For me, a lot of things that come up are, kind of like the PDF parsing. And I think Unstructured has done an incredible job of like specializing on that. We just had a podcast with David DeMatthew, who moved from Noom AI to VetRec, but he was talking about how he had contributed this CSV loader, and people found like a ton of value out of that because, like, and it's really funny how he tells it like they were building this super advanced distributed messaging queue, and just having like a CSV loader was something that people were like, yes, we love this so much. And so yeah, I just really like to kind of take down like, extracting knowledge graph tuples, and just, that whole, if we could just open the box and maybe just, yeah.
Yeah, like I think basically the ingestion phase is you have all these documents and you want to get them into some sort of form where you can query it. And like you're saying with unstructured and PDFs, like taking these massive PDFs that aren't necessarily even like well formatted documents. They could just be like scanned images of like some old newspapers or something. And like, how do you do OCR and stuff to like get data out of those into a way you can embed and index it is like in its own like a very complicated process. And then sort of related to that, one thing I was wondering about recently is you can almost think of like PDFs as like a modality. And so like this multimodal RAG type stuff, like what does it look like when in the ingestion phase you're introducing more modalities? So like if you sort of consider each file format a modality, you could extend that to be like, how do you process an image and get that into your database? How do you process a video and get that into a database? Like right now, you could already take some naive approaches where you just get a transcript of the video and then you have text, and all of a sudden you can embed that text, right? And that's one way to get your vector database populated with information about videos. But what will it look like when we have models that will directly embed a video and can capture more information than just the transcript? So like I think this whole ingestion area is ripe for like a lot of development and like new techniques to come around.
Yeah, I love the multimodal angle. I've been like using Cloud Pro. In my opinion, it's just been the most advanced chat with PDF type of system I've seen, and sort of having it like, you drag and drop an archive paper, and then you say, "Could you explain Figure 2 to me?" And it seems to have more. I guess because I used to think that the solution to this was going to be the image captioning models that would kind of like translate an image to text, and then you just have the text. But yeah, I think there maybe is something to embedding the images. I guess maybe zooming, like, going deeper into this kind of PDF parser, what this will look like in the kind of ETL and vector database spaces. I imagine there's kind of like, what does the microservice architecture look like? Like you have this inference for the, the OCR model. You also have, say, the image embedding model for Figure 2, and then you have the text embeddings, like the chunking, and then you also have the kind of like this part whole hierarchy distributed messaging queue type of system. Yeah, and then I guess also there's this question of like the client server sort of design. Like, is it about, get all my data into the thing and then it starts processing it, or does it kind of happen like incrementally? Yeah.
Yeah, I feel like most of the processing right now happens incrementally offline, right? Like if you think about it, generally when you're going to these systems and asking for a response, the data should have already been processed. Like when you're querying the response, you probably already have a knowledge base. Like if you're writing an application that's like an expert on tax law and stuff like that, like you're already going to have processed the massive amount of documentation about how to file your taxes. And so it's uncommon, I think, right now for this data processing piece to be happening on the fly. I think where it starts becoming more relevant is when you start introducing in your search other data sources. So, like when you're
Mm.
pulling information from the internet and searching for more recent articles, or letting it sort of be a more open-ended search, because you obviously can't index everything, right? Um, so once you start doing that, then you need your uh, sort of document processing to be as fast as possible, assuming you want fast responses, right? Which, like, no user is going to wait like 5 minutes for uh,
Mm.
your GPT to go like get these PDFs and like slowly process them and stuff. So it can be really important for that to be fast when you are in that sort of operating model.
Yeah. Yeah. So I think right there we've got a lot of topics in there. Like context fusion, combining the context fusion is something Erica came up with that Weaviate to describe, like, vector database plus knowledge graphs or plus web search, or just two different indexes like blogs and podcast clips. And yeah, that 5 minutes, the latency thing, that's definitely something we're going to open up as well. But that tax law thing to begin with, there's just one more thing kind of finishing this PDF parsing I want to explore further, which is like, I imagine when you're looking at, like we looked at a lot of SEC 10K filings, it's like some dog food to kind of study these systems. And you see a table, and now you want to parse out a table. Do you think, like, how are you thinking the current practices on parsing tables? Is it you maybe have like an image classifier that says this is a table, and then how do you then extract the sort of the structure of it, and how do you think about then putting that into, so that's kind of this design of systems where the ETL is, say, maybe extracting knowledge graph tuples or chunks for vector databases, or kind of like symbolic metadata, like and the symbolic metadata one is interesting because it could be something that's explicitly a table in the thing it's parsing, or maybe it's like coming up with metadata about the say it's a
Yeah.
podcast transcription. Yes. How do you think about that current thing of like, I guess this topic would be sort of like ETL for vector knowledge graph, symbolic systems, symbolic like SQL systems. Yeah.
Yeah, I think that's a really great question, is like, how do you process like tables and these other things and enrich them with like extra information, and sort of pack the representation with like good keywords and tags and stuff. So I think one important uh, aspect of this is uh, using specialized embedding models, right? Um,
Mm.
when you're taking all of these different kinds of information, like all of the tax law, that is going to have a very different structure than like all of the English Wikipedia, right? So you're going to want to have like a fine-tuned embedding model that knows how to process the particular kinds of information that you're going to be adding to your knowledge base, and that will give you a lot of performance boost. You can sort of think about it like if you have a massive vector space with your just plain old like embedding model from OpenAI or something, they're going to use that whole space. And then when you have the all the tax documents within that entire space, they're going to be fit into a very narrow segment of that space because they're all sort of
Mm.
related to tax. And so by fine tuning the embedding model, you can take that narrow space and sort of blow it back up to the entire dimensionality of your vectors and get much better results to build those connections between things. And so, like, I think that can contribute a lot to when you have these specific needs for processing tables or whatever your needs are, is to like fine tune the embedding model.
Hmm. I think this is a big one. This is something that I've started playing with code embeddings after our podcast with Tangyu. I was like, I have to try this Voyage code model, and something that I think is really interesting is kind of having that whole like a summary of. So again, I really like this like part whole abstraction of thinking about how you're chunking up like code or something, and you have the whole of like the package it's in. And I really like this idea of the summary index. I originally liked the summary index for the sake of like, you have a big paragraph that you're embedding, and so you have a summary of it that you embed, and then it's easier to search with. But I think this idea of like you summarize the whole, so to say, so like you summarize the package, and then you have that summary in addition to the function, and then that's sort of what's used as input to the embedding. And that opens up this box of the systems that do the embeddings, because now you have like, now it like does maybe like the refined summary from LangChain, where you had that like please summarize these documents. You'll receive the documents one at a time, as well as a summary so far, as a way to overcome the context limitations. Maybe with these long context models, we can just kind of, give it all and say, how about a summary for this? But so yeah, what do you think about that kind of like adding context to the embeddings, like getting some information about the context it's in that helps it embed it better? And it's also kind of related to what you're saying about embedding space, where this is a conversation. This is the topic that always comes up on the podcast, is that zero shot versus fine tuning thing. And I sort of believe that you can prompt a zero shot embed, even in an embedding model, like same way as with RAG and LLMs, that if you give it some information about the domain, it can help it do the embedding. Yeah, what do you think about that?
Yeah, that's really interesting. I definitely think one of the points you made about like the large context windows, I think it is really fascinating seeing these like million token context windows, but then you're also paying for a million tokens on every query, right?
Yeah.
So even with them being so large, it's not necessarily the silver bullet, right? Um, and then as far as, um, sorry, I forgot your other question.
Oh yeah. I guess like I really like the kind of summary chains. I think
Summary chains.
yeah.
Cool. Yeah. So, and then as far as summary chains go, um, yeah, I think the recursive summarization is like a great tool for preparing data for embedding. So you start like by like you're mentioning, summarizing a paragraph, then you can summarize a whole section and summarize, like just recursively go up until you get um, better and better, like more coarse grained summaries. And that's a good way to like do some like multi-layered search where like you don't necessarily want to search across all of the chunks of information you have. Maybe first you want to narrow it down to a specific set of documents that you search for. And then within the documents, you search for chunks. And so it can be really helpful for making sure that you get the right documents in front of you as a whole, rather than picking random chunks from a bunch of disparate data sources.
Yeah, I think that's an amazing one. I think in Llama Index, they call that the recursive retrieval. And we did some experiments where we'd have like Hugging Faces blog posts, Weaviate's blog posts, so on. And so you first search through through like the description of the blog post and then the chunk within the blog post. And yeah, we found that to be just super effective, such an interesting way to do search. But yeah, and then that kind of like two level vector distances that you do, that's also something that could be really interesting for Weaviate. I'm also curious, like, so Weaviate, we now have multi-vector support. So I think you could maybe just have like the blog context as kind of one of the vectors, and then the chunk embedding. So the whole, this is really going to be saying this whole thing a lot while we're doing the ingesting data topic, but so like you'll have the kind of the whole context embedding as well as the chunk embedding, and you can kind of work around it with that. And Vespa has a really nice blog post around that as well, and how they integrate that with HNSW traversal, and there's kind of some stuff you can do there. Awesome. So I think that's a pretty good coverage of ingestion. I have one more question for you on this, which is, we're talking a lot about this kind of like all this stuff you can do. Like you can be splitting the data again to extract knowledge graph tuples, chunk it. And then I'm curious about this idea of the GPUs, like in the embeddings. Do you think we're going to still have these sort of embeddings APIs, or do you think it makes sense for people to, you mentioned fine tuning earlier. If you're fine tuning, you have your own PyTorch model, and you might want to host your own embeddings. What do you think about the state of that?
Yeah, I think that will be relevant for some people. I think it largely depends on sort of like if you can get your hands on GPUs and you want to like go through the burden of maintaining that system versus just using a service for something like that. I think that's, to me, that seems like more of the cost trade-off is, do you want to spend time maintaining your own GPUs? So, and then you'll get like a lot of performance and cost savings because it's going to be a lot cheaper to run your own inference rather than using like inference from some other service. And then the other use case, I think, where this kind of thing is really relevant is when you have people in certain sectors where they need really strict data access control. So like if you're in healthcare or legal or finance or something, and you have to like guarantee that your data is not leaving your servers, then you're going to need to be able to figure out how to fine tune these models or not even fine tune, but just get like a copy of them and running your inference locally rather than sending it off to OpenAI or some other service, because you have these like really strict requirements around data. And I think that's also like an important part of the market that where that's like super relevant for.
Hmm. Yeah, it's a pretty interesting one. What you said about kind of managing your own GPU system sort of resonated with me a lot. That's sort of what I would say the status is now. Is if you're going to have like even like eight H100s, or I don't know, like it depends totally on who we're talking about. Like it adds a whole nother complexity there, and I do think kind of just the embeddings API are more so the status of how people are doing this, but. We've seen some really interesting things with Modal, particularly something that stands out to me, where they have these demos of spinning up these embedding workflows. Jason Liu has a great blog post. Charles Fry is doing a lot of cool stuff on like how they're maximizing sort of batch throughput with their system, and it's a really interesting case for kind of open source embedding models. And it just is another thing that's sort of shaking it all up. Awesome. So I think that was a great kind of coverage of ingestion topics. Now, can we move into search, and how are you currently looking at search?
Sure. Yeah. So search is all about sort of finding the right information. And so one of the things that's sort of relevant here is like figuring out how to know like when you even need to do RAG. Like when someone sends you a query, what is the thing that says that I need to go search for this knowledge through this knowledge base? And if you have multiple knowledge bases, um, what sort of determines which knowledge base to uh, send a request to? So this is where things like chain of thought prompting and this concept of like cyclic generation come into play. Um, so chain of thought prompting is basically where you first ask the large language model to break a task up into a series of steps, right? And you get like a list of things to do one by one. And then cyclic generation is conceptually it's where there's multiple back and forth processes between the search phase and the answer phase, um, where if you sort of imagine how like a human would search for information, you normally perform a search, get some information that sort of answers maybe part of your question, and then you take that information and use that to inform your next search, and you do like this process of several searches while you're researching a topic or looking for an answer to some information. And so that's where the cyclic aspect of cyclic generation comes from. And you have this back and forth until the LLM is sort of satisfied with that it has the information it needs to answer the question. And I think those two techniques are like really helpful for getting good search results.
Yeah, I think you're hitting on one of the most powerful things out there right now, and there's just so much to this topic of this. Yeah, this I love the cyclic generation abstraction of thinking about it. This kind of like query rewriters, query generators is so interesting. I see even with Cohere's Command R model, they have this thing built in. Like one of the arguments you can give it is to have it return to you the search queries it generates, and so it even shows that we're kind of like Cohere there sort of stepping beyond just kind of like LLM as an API. It's kind of like a whole RAG system, it seems, and you can also give it documents. So I find just that to be a super interesting development, but also just yeah, like routing. I think routing is just such a big topic we can open up, and it has so many things. I guess maybe a good place to start would be this kind of thinking of like you have a query come in and you classify like or you generate some kind of query. Maybe it was something to kick this off is I really love this Gorilla project from Berkeley that's about like now it's really about function calling and kind of that JSON way, and I just kind of like generally interpreted it to mean like use APIs, and we have developed all these APIs like similar to RagKit, of course, where you have all these APIs, and so that kind of like routing to me, I feel like it could just take a query and then just generate like a RagKit query, and that sort of would be my current perspective on routing. It could all just be one model.
Yeah, I think I like that idea where you have like just one super optimized model that sits like at the front of your query, and its job isn't at all to answer the query. It's more to break it up into steps. It knows about um, which tools you have like available, what your knowledge bases are, and it just like acts as a router for sending off queries to other uh, models or like prepared prompts or agents or whatever else you have in your system, and it knows how to do that routing. I think that's like a really powerful paradigm to help like get really good fast results.
Yeah, and I guess the other question I'd want to, yeah, so that kind of like tool use, function calling, that perspective would be you give tools as input to one of these language models that supports function calling, like OpenAI and the Gorilla, of course, and I think also Anyscale has function calling on top of say Llama 2 and models like this. So you would give it each of say with RagKit, you have like search with re-ranking or hybrid search or maybe symbolic search or like not even like search, more like like select all from aggregate those kind of searches. And so you'd like interface each of those as like a JSON. So yeah, what are your thoughts on function calling currently and that kind of perspective on tool use for the sake of like query transformation?
Yeah, I mean, I think how you define your tools and like make them available is really interesting. I don't know if this is a good time. Maybe I can talk about some of the gist token stuff. So
Cool.
you're talking about like in your prompts, you sort of have to say what tools are available, right? And so if you have this list of tools and like what function calls the large language models can do, um, then if you're describing all of these tools, that's going to take up a lot of tokens that you're charged for when you're sending that to a large language model. So, uh, one way to sort of get around that is one of the traditional ways is to like fine tune your large language model so that it just understands the task that it's meant to be doing, right? But that's not as flexible, right? Like if you want to add one more tool, then you have to fine tune your model again, right?
Oh.
And that can be really expensive. So there's this recent paper about gist tokens. So just like get the gist of something. Um, these gist tokens are a way to sort of make this more flexible and still accomplish like significant prompt compression. Um, so the idea is like, let's take a step back and look at how LLMs work. Like they don't get the natural language that you're typing in your prompt. They're first converted to tokens, right? And so the tokens are just an integer that the LLM sees. And right now, this is done through some sort of tokenizer, and tokens are about 4 characters long on average, right? But there's nothing that says a token has to be 4 characters long, right? That's just sort of what we've learned through like analyzing some corpus of information that 4 character long tokens works pretty well with large language models. Um, but you can extend the set of tokens to include special tokens. And we already see this. This is like a pretty common practice with like a end of text token that tells the large language model to stop responding, or tokens to specify that it's a system message versus a user message and to treat them differently, kind of thing. So these special tokens you can add on to your uh, tokenizer and your like available sort of vocabulary there. And so the concept of a gist token is to take these parts of your your prompt, so like the information about all the tools you're using or the tools that are available, and you can break them apart and add them as sort of a special token. And then you take those special tokens and you obviously have to train the model to understand them. So you do a fine tuning round on top of this and teach the model how to understand these new tokens you've introduced. And then when you send a prompt, you can use some combination of these gist tokens. So maybe one of the tokens represents like give me a summary. Maybe one represents like give me JSON output. Maybe there's like one for each available knowledge base that you want to use in that prompt kind of thing. And you can sort of configure them so that each of these sort of pieces of the instruction set only take up a single token rather than taking up hundreds of tokens or whatever. And this sort of compresses the prompt significantly and gives you a little bit more flexibility over just like fine tuning to like a fixed set of tools. And so I think this is like a really interesting technique that has recently been published.
Yeah, I'm fascinated by what you're saying. I mean, because I guess usually you have kind of like the name of the function, the short description of what it does, like this summarizes documents or whatever, and then the input arguments. And if you can compress that all into like, angle bracket SUM, closed angle bracket. And I guess, yeah, that one is just absolutely fascinating. I guess it's like, I guess for me on that one, and I wrote down so many notes when you're talking. I'm like trying to think of how to parse this out in my response. But this, like, I guess something that makes function call. Well, so this kind of gist token thing. If you have to fine tune the model to follow the compressed tokens, I guess for me, then it would be like you might as well just do the Gorilla approach, where you're going to fine tune the model to translate queries into like an entire API kind of. But yeah.
Yeah, so I think that that does work for maybe tool use. If you have a fixed set of tools, then you're not necessarily going to get much difference there. I think the benefits come with like the flexibility gist tokens give you, where you can like, if you have a set of tools, but you don't necessarily want all tools to be available all the time, right? And you want a limited subset of it,
Yeah.
like that can be really hard to communicate. You either have to, you obviously can't fine tune every subset of tools that you want to turn on and off. And so either you have to have some way of doing that. And gist tokens are like a pretty elegant solution where you can define a tool as each token and do something. You give it some examples like your normal fine tuning and compress the prompt in that way. So I know the paper talks about it a fair bit, and they claim to be able to get like up to 26 times compression on prompts with not much loss in output quality. So like the concept seems really promising.
Yeah, that idea of turning off certain tools is really fascinating. I guess it's like maybe like kind of like when you have a private information retreat, like you have like web search as well, and you have some system where some of it runs on prem with like Weaviate would be in your private thing, and you don't want any of these questions to be off to the UAPI. And so it's like, hey, you can't use web search with this one. Yeah, I really like that one. I guess I guess we could definitely go into the details of like how you would decode and do this kind of tool sampling. I guess kind of like one thing really quickly I wanted to get your take on is this kind of like pydantic model validation for the sake of giving the right input arguments for tool use. So like if you're writing one of the Weaviate APIs, and I've tried this myself and seen the problem where it'll like hallucinate arguments to the APIs, and this is one of the big problems. And the pydantic model validation thing, I think what I appreciated about it a lot is that it will give you that kind of like a validation error and maybe give you more information, and you can easily have this kind of like type checking and particular kind of errors it's going to then send to the model to retry. So yeah, I guess maybe if I could just get your take on like this kind of pydantic model validation and how it plays with function calling and sort of like how important that is.
Yeah, I think in general that kind of type checking is very important. It makes everything like a lot more usable and user friendly to just like in sort of any system you want to have a good sense of the types and not just be accepting arbitrary stuff to these function calls. Like you want to know what the arguments are, or it makes it very hard to use. So like being able to validate the types with these pydantic models and stuff, I think is like very beneficial for sure.
Yeah, yeah. Sorry, there's a lot of loud sirens going on
Um,
in the background. But, so I guess I think we both kind of are now agreeing that sort of like routing and tool use. I think we both agree that we think these are kind of similar ideas.
yep.
So then on the other side of the kind of search relevance coin is sort of like the sorry, there's a fire truck involved now, so it's kind of
So weird.
distracting me. But is also like this kind of like ranking and sort of like user features and like recommendations. So I think that's kind of like a whole nother sort of topic where I'm Connor searching routing layers, and maybe you have this bias of like Connor wants to see DSPy tutorials, so you kind of have like user features as well. How do you think about like re-ranking and recommendation systems and how it fits in this picture?
Yeah, so I think re-ranking is really interesting. It's this is definitely like a really important topic for getting the best results into the context window. Um, so like generally you'll get the top 10, 20, 30 chunks that are just through like a fast vector search of some sort. And then re-rank those to pick maybe the top three. And there's a bunch of different strategies for re-ranking that I think are really interesting. One example is sort of using document perplexity to
Mm.
figure out which of the chunks are most relevant. So the way that sort of works is if you imagine you have your 20 chunks that you've pulled from just like a coarse fast query, um, and then you want to like actually do and the re-ranking and implement a re-ranker. One way to do that is to take one chunk at a time and send that with the initial query to a large language model. And when the large language model responds, um, it'll give you the log likelihoods of each token at a particular point. So you can sort of see how likely the large language model was uh, going to generate that answer. Um, and so then you look over the entire answer and see if sort of calculate the perplexity, which is a term for there's like a mathematical definition and stuff that I won't get into, but it sort of like if the large language model is confused and like it has like a bunch of different answers or it's not like really certain about which token it's going to generate, then it'll have a high perplexity. But if it's like really certain and it's like 99%, it's always this token, this token, this token. And so it's sort of like really confident in its answer. Um, then you get a better perplexity score. And so if the document that you provide gives a good perplexity score, then that's like a high quality document probably because it helps the LLM generate a confident answer. Um, that's just like one of the many heuristics you can use for this kind of re-ranking. And importantly, this isn't the actual answer you're generating. So you don't have to run this on the best LLM. You can use some cheaper or open source models on your own inference things. You're just looking for the perplexity. This isn't the answer itself. So it's not like you're throwing the 20 prompts into GPT-4. It's just trying to get the perplexity score from other models. And so that's one really interesting way I've found to uh, do that re-ranking.
Yeah, that's so fascinating. I had kind of forgotten about that one, to be honest, and I love that you brought it back up. We had explored. Erica did a blog post on using Cohere's re-ranker fine tuning, where you're fine tuning their cross encoders. And so cross encoders, they take as input a query and a document candidate and output a relevance score, then another document candidate and the query, and so on. And then there's also this kind of like list-wise re-rankers, something that's in the air where the query, where the you have like a big re-ranker model that takes as input the query and all the candidate documents. And I guess you can imagine you have that kind of like cross attention over all the documents. And that's quite an interesting idea. And then there's also kind of like the Colbert thing where you have that kind of re-ranking with document vectors. But yeah, let's really zoom into this. I really like what you said at the end as well about that kind of with the perplexity evaluation of document relevance, you can compress the model. You could use GPT-4 to maybe for a query. It's maybe it's the listwise thing to produce your training data, where it gives you like the top 5 most similar documents, and then you're language modeling those particularly. And yeah, I guess the question for me would then be, like in DSPy, I think the smallest model that people are fine tuning is like the T5 large, which is like 700 million parameters. And I guess the question then is, how small can you make such a model and it's still effective? And then this comes back to our discussion on the GPU tooling, is like, how much of a pain is it going to be for developers listening to us who are going, okay, I'm going to re-rank with Perplexity, and now you want to parallelize, because you say you have 100 candidate documents, and now you can have this T5 large. It's going to Perplexity your query in each of those candidates, and now you have to have a GPU and all that kind of inference batching, and you have to do
Yeah.
locking and stuff. Yeah.
Yeah. I mean, I think you can probably get away. I haven't seen like what the actual like metric numbers are for each of these newer models, but I think you can probably get away with like these smaller models for this kind of step, because it's not like this isn't the end user output, and you don't necessarily need um, it to be perfect, because you're just trying to get like a relative ranking of these documents. And it definitely with this kind of an approach, it's very easily parallelizable, right? Like each of these prompts is independent. Like you just split it up into 20 prompts and send them all off at once in a batch or something. And so there's like not any reason that you have to do them in a row. So like having these quick re-ranking models like in like a local GPU in wherever your cluster is or something, I think can be like really beneficial to just like speed that aspect of your pipeline up.
Yeah, super cool. And yeah, so that sounds like a super interesting way to do it, and I certainly agree that could be a major part for kind of just ranking. But I kind of like one other thing I wanted to touch on the original question was with this sort of like metadata in addition to the query. So it's kind of like Connor and I'm saying basketball shoes, but you have this kind of like feature that that like I particularly like LeBron James shoes, let's say, right? And so I'm kind of curious about that system design of like. How you bring the user features forward, whether you should like maybe have a ranking expression, or if you should have this be like a part of the prompt, like if the prompt says please boost search results that have this metadata tag LeBron James, or like color, it's like I like blue sneakers, let's say, something like that. If that is kind of the architecture of like it's in a prompt, or if maybe we see this kind of like XGBoost thing return, where like vector distance, BM25 score, these are like two features, as well as like a normalized score for the color, price, these kind of things, and you have that kind of system.
Yeah, that's really interesting. I haven't given a lot of thought to that. I'd say like I want to say that there should be a solution outside of the prompt. Like if you're putting this information into the prompt, it feels like capturing like everything it means to be Connor and putting it into the prompt, right? And all your preferences, like that's going to like be a losing game where you just keep adding more and more information, and it slows down the prompt and it increases the cost. So like what's the right approach to take there? I'm not sure exactly what the answer is, but um, the prompting seems like it would be tricky. Maybe you can sort of tie this together with that recursive summarization approach, where like you get all of Connor's preferences and then summarize them, and you can put that into the prompt, or something like that, or have it summarize your preferences as it's related to the current query that it's executing, right? Um,
Yeah, I think what you're saying now will bring us really nicely into the kind of third pillar of responding, which is I really like with MemGPT how it has this kind of meta prompt where it's like, you have a limited context window, so we're going to have to get rid of some of this conversation history. You have a database, how would you like to organize it? And I also really like this kind of like multi-agent persona type of system. And so I think as we're studying recommendation systems and learning about preferences, I love that you mentioned this kind of like recursive summary of my preferences. I'm looking at my history and I'm saying like who am I? What are my preferences? I actually think this is how consciousness, like this is my personal theory of how consciousness will arise, is because you have the language models like constantly doing that theory of mind, and there are also like theory of mind benchmarks now where it's really becoming a thing. But like if you have RAG with persona, and let's just say we have Kyle and Connor, and both of these chatbots are like looking at the conversation history and forming like, well, these are my preferences. This is who I am, sort of. Yeah. What do you think about that kind of like? Yeah, that I guess like extending from the human preference thing to thinking about personas like LLMs and like maybe multi-agent systems. They have preferences, and you can imagine pretty wild systems that might.
Yeah. Yeah, I definitely think like agent based approaches are really powerful, and
Hmm.
like being able to um, sort of define an agent that's like really good at particular kinds of tasks, and then you can just like iteratively over time make that agent better and better at the task as you get more data or as you learn more things, and have it like super good at summarization or super good at finding the right Wikipedia article or like whatever task you've set it out to do. And you can even define it as sort of an expert in an area. So like if you want to have an agent that's an expert at like football history questions or something, right? You can like make these very special purpose things. And then going back to sort of that routing idea we had earlier, like having agent or some other thing that knows about the other agents and can route queries to all these special purpose agents. And
Hmm.
having this sort of network of a bunch of experts is like a very powerful paradigm to um, getting really good answers, because it's really hard to make one agent that's good at everything, but it's a much more approachable task if you know you're going to be dealing with a certain kind of query a lot, to make an agent that's good at that kind of query.
Hmm. Yeah, well, you've just killed my belief that you can just have kind of one function calling prompt for all. Yeah, I love that. Like, it also comes back to what you're mentioning about restricting the amount of tools that you can use. Like, if you have this perspective of the query router, it has the tools of the other agents that it's going to pick, and then they have tools, and you have that kind of like one layer agents. That's a pretty interesting one. I guess with agents, and also kind of coming back to that cyclical generation kind of thing where you're looping and you can just, I think that was like the auto GPT thing that just captured like everyone's imagination. I've started to not like the agent abstraction, firstly because Omar had a problem with it, and I was like interested in his perspective. But I think that this kind of like agency is sort of like uniquely human. Like that, like I kind of like the pipeline abstraction, or like the task abstraction maybe a little more than agents. Be,
Yeah.
yeah.
Yeah, I think that's like a good abstraction. And I think like agent can mean a lot of different things to different people. Like I view it more of like an agent is good at solving a problem. So it's really identity is associated with the problem and types of problems it's trying to solve. And that can be like a wide range of things. Like maybe it has access to tools, maybe it doesn't. Maybe it's just like a special purpose LLM you've made, or maybe it's like an agent that is really good at embedding stuff. So maybe it's like an embedding agent. Like I attach that word to the problem itself. So maybe other people are, maybe that's not the right way to be using the word, but that's definitely how I think about it.
Yeah, you got me back on the back on the yeah, because I love the embedding agent like as a way of thinking about, you have this abstraction of, you have all these subtasks that you could do, and you have to say, "Am I finished?" and you have to kind of orchestrate it all. And I do think agent works pretty well there. But then when I see demos of like, here's my agent buying me a plane ticket, right? And I'm like, well, I would like to say, go ahead and spend the money on the plane ticket. I don't want it to just do that. And so that's, I guess, kind of where I think about that like agency thing. But let's now kind of, I think we've already kind of started transitioning into sort of the LLM part. It's hard to kind of even talk about search without the kind of LLM component at this point as well, I feel like. But if we kind of talk about like responding and building a response. And awesome. So I think that was a really great overview of search. And I think we kind of started talking about agents and cyclical generation, and we sort of blended respond as well into the 2 and 3 pillars. And I love how the kind of the purpose of these conversations is hopefully to come up with our, flesh out our abstractions. And because I guess like with search and cyclical generation, you can always just kind of like search and then inspect the search results and trigger another search result. So it is very like agentic. And I think kind of, and then now let's come into evaluation, because evaluation is such an interesting one, with especially how we've just described like search used to measure like NDCG and precision recall, but now I think we're more so looking at just answer quality. And yeah, I'd love to just hear your thoughts on the current state of RAG evaluation.
Yeah, so RAG evaluation I think is really interesting. There's a really good open source framework for it right now that is called Ragus. I think we mentioned it earlier, and you've done a podcast with them, I believe. So there's a lot more detail out there if people are interested in that. But that's been a framework that I think does a good job of splitting up the difference between like how the LLM is performing and how the retrieval is performing, right? Okay. Because if the LLM is super smart and can answer the question correctly, but it's not using any of the context that you're providing, like all your users might love the answer, but the retrieval's like not good. It's not giving anything relevant to your LLM. So Ragus has a set of metrics that are good at distinguishing these sort of different cases. So maybe I can just like go over the 4 main metrics they have that I think are really good. So the first one is called faithfulness, which is just like the factual consistency of the answer. So an example would be as if you give a question or about like when and where Einstein was born, and in the context you have that he's born in Germany on March 14th. Then a high faithfulness answer would be that Einstein was born in Germany on March 14th. And then a low faithfulness answer would be that Einstein was born in Germany on March 20th, which is incorrect. So it's like the factual consistency of the answer. So the way you sort of compute a lot of these metrics in the Ragus framework is you have some other LLM extract some data about the answer. So it would pull out like what are the relevant like facts in this answer. And one is that Einstein was born in Germany. One is that Einstein was born on March 20th. And then you just measure how many of those are correct based on that initial context. And so you would, in the case where the date was wrong, would have like a faithfulness score of 0.5 because one of the 2 claims was wrong. And so that's how that one works. The other 3, answer relevancy, is how relevant an answer is to the initial question. And I think this one is really fascinating. So the idea is to penalize questions with incomplete or redundant information. And I think the way it's calculated is really interesting. So the theory Ragus has is that if the answer is highly relevant to the question, then you should be able to take that answer and generate similar questions. So what they do is take your answer, generate some hypothetical questions that would produce that answer using an LLM, and then measure like cosine similarity between the original question and those generated questions to see how relevant the answer is to the original question. And I think that's like a really fascinating technique to just like generate questions from the answer. Then I can keep going over the other 2. So there's context precision. So just a measure of like how good the chunks you're putting into context are. So like if you're putting a bunch of unnecessary information into your context, then you have some problem with your retrieval pipeline. And then the last one is context recall, which is just like how much of the answer can be attributed to the retrieved context. And this one is kind of interesting, where like um, the answer can be completely correct, but if it's not in the like context that you've added, then you might want to penalize the LLM for that answer. Um, so if the question is about like, or if the answer is that France is in Western Europe and its capital is Paris, and then the context only has information about where France is, and the LLM just sort of decided to add that the capital is Paris, even though you weren't able to get that from any of your retrieved information, that might not be ideal, because it's, even though it's correct, you might want be in a domain where it's very important to have citations on everything you're saying, right? And in that kind of a case, there you don't have a citation for the fact that Paris is the capital of France, and so I think that's like an interesting uh, sort of play there, where like the answer is totally correct, but you penalize it because it's sort of adding this extra information, even if it was asked for, that's not in the context.
Hmm. Yeah, wow. So I think there's so much to that, and it's such a deep topic, that kind of evaluation. I love the nugget of, generate a question from the answer. How similar is that to the question? It kind of reminds me of like round trip consistency for synthetic queries, where you take an answer, you generate a synthetic query, and then you search it to return that document that you produce a synthetic query from. And there are definitely all these like heuristics like this. I guess from like a systems perspective, I've been really liking Arise's Phoenix tool, and it's helping. It's like what I'm using for my DSPy development, and seeing like logging my calls. And I can imagine you sort of like attach these calls to Ragus, and then you have the labeling of those scores is like one way to monitor it, sort of like in production, as you would say, like as it's running. And I guess like the topic that I'd want is, there's like a couple, there's two that I really want to zoom in, and the first of which is so like this kind of like earlier we talked about like multi-hop query generation, where you take a query and then you write like another query, and now you have like this like really open-ended way of like exploring information. And I'm kind of like, how do you like, and you mentioned like kind of penalizing it for adding an extra sentence that's like not quite like the most succinct answer, but it's like, how do you capture like it went and found some information because it did like a web search, and now it's like not quite contained in the gold answer, but it's like it is useful, right? So that's kind of where I'm having a really hard time with my personal development and trying to evaluate these multi-hop query systems.
Yeah, that's a great question. I think um, this is like a really hard problem. Like figuring out. So right now, like a lot of these metrics are saying how good the resulting
Hmm.
chunks you eventually find are, but like how do you measure that in between phase? Like maybe it ended up using the wrong tool. Um, and honestly, I don't have a great question or a great answer there. Like I think these are great questions that a lot of research is going into, like figuring out how you like measure these systems in a way that you can sort of inspect the inner workings a little bit better and have a good pulse about like which tools they're using, and how do you decide that that tool was actually the right tool to use in that situation. um, yeah, that's a really great question. I'll have to go think about.
Yeah, and I think everyone's thinking about, like, I think vibes. That's like the current, like what people say they evaluate LLMs with. And I think like if we're thinking about like like today we're recording this podcast, and Mosaic ML Databricks has their DBRX model that they've published with like the MMLU benchmark. I think I'm blanking on the name of the code test one, but like say the MMLU benchmark, comparing that with say the chat, is it called Chat Arena? Sorry, I'm just blanking.
Yeah,
The
chat arena.
Berkeley, yeah, is that the Berkeley one? I think it's LMSys. Yeah, yeah, I think people know,
Yeah,
but like they have this scoring system where say GPT-4 talks to Cloud 3 Opus, and then another LM says this LLM was smarter in the conversation, and they get like an ELO rating, and it's like a game of doing it. And I think we also need to adopt this kind of mindset into our RAG evaluation. I think I need to have, because I'm always only evaluating it for the sake of uh, I have multiple configurations of the system. So I think kind of adding that sort of like LLM wins, like kind of head to head. Here's the answer from system A, B, C, D. Which do you prefer? I think we need to have that kind of
Yeah,
direction.
yeah, I really like that idea. I think like these ELO based systems are great at you do a head to head comparison, which is generally really easy to say which one is better or not. And it gives you this global ranking of what to do. So that's a really interesting idea to like, instead of maybe using one tool at every step, you have it pick like the top two tools or top couple of tools and do like a head to head thing with those within your own system to sort of see which tools are actually performing the best, and which tools you might need to refine more or like take out of your system. Um, I like that idea.
Yeah, it's a deep one. This whole evaluation topic is a tough one. I guess for my development, I'm just still using kind of like, I have my RAG program and I run through it with GPT-4, and these are the gold answers, and and then I have that kind of weighted metric Ragus style where how grounded in the context is it, how detailed is it, and then how aligned with this gold answer is it. That's the best thing I have personally. But I do think this kind of like scoring of multiple systems. The problem there, though, is then you need to have some kind of like weighting in your optimization system where you kind of like sync up all the configurations to get that kind of metric. And but I do think that'll be a big part of the future of this. Awesome. So I think that was a great tour of the pillars. If we could maybe kind of come into now, RagKit, building clients. I think this is a big thing about like RagKit. Weaviate is understanding the future of kind of client server architecture with compound AI systems. Could we maybe just sort of kick it off broadly with how you see the kind of like client design?
Yeah, I think client design is really interesting. Right now, like you have like the fundamental pieces are super important, right? Like the feature set that is available and that it's performant and correct and stuff. But then you have like a bunch of these other things that play a big role. So like the developer experience, the documentation, having a good playground, having like sensible defaults and like good editor support. Like all of these are really critical to having a client that people want to use. And I know I saw the Weaviate, the Python client upgrade. They improved the defaults and performance and like the IDE support. So it's good to see that those sort of stuff improvements are happening. Um, but I think like those things are important. Otherwise, you're just sort of fighting an uphill battle to get people to use your clients. Um, and one interesting thing I've seen in the space that uh, has been going on for a while, but is taking your uh, sort of generating your clients. So instead of like handwriting each of your clients in these different languages, you can write an open API spec. Notice open API, not open AI. That's easily confused in this sort of setting. But an open API spec that sort of defines just like what your endpoints are. And there's a lot of tools that will take that spec and generate clients for dozens of languages. And that's like a really interesting concept to me because it can sort of let that generation tool handle figuring out what are the best practices and paradigms that are most relevant in those languages because you're not going to be an expert in dozens of languages, and they're going to be like changing a lot. So uh, I think that's a really interesting concept that is starting to happen a fair bit more.
Hmm. Yeah, the developer experience angle is definitely a super fascinating one because I guess like the clients they kind of like have abstractions. This is kind of like the clients they provide like these suggested APIs, suggested things you can do with it, and so it's kind of like a that's kind of the purpose of and now we have this like really smart co-pilots that can really use the abstractions behind it. And so I guess this is something that I think Another paper I'd seen is backtracing. This is another paper from Rose Wang, and Omar Khattab is on this as well, where they take questions and then they map them back into the source. So if you have a question, like we with Weaviate, we get questions in like our forum or our Slack all the time, or Stack Overflow, and say you could take that question and then like the LLM can map it back to its source and then propose like a new design for it. And so I kind of think like with clients, they're going to have this sort of like self-healing evolution of their APIs where they can go from questions, go from developer confusion, and just like directly update the abstractions. What do you think about that kind of idea?
Yeah, that's incredibly fascinating. Like the idea of sort of taking this client generation a step further and like having your support forum or Slack or Discord or wherever you get questions, and having a LLM take those questions and then go find where there is customer confusion in your API design, and then go suggest changes and update it to fix that. Um, I think that'd be amazing. I want to see someone build that, and like how effective that will be. I know we're starting to see LLMs that are like handling basic coding tasks on GitHub automatically and stuff. And like, how is this gonna? Are they going to be able to field requests like that and like make client updates in that way? Would be really fascinating.
Yeah, and I think because the kind of the other thing is like the clients tend to be able to like move faster than the database APIs, kind of, and so I think they'll probably benefit more from that kind of like GitHub issue to new API. Like just the turnaround time, I think will be much faster, and that is kind of like what that generated clients from an open API spec just kind of gets me thinking about that kind of direction. Awesome, cool. So yeah, and I'm definitely not too much of an expert on the developer experience. There's people at Weaviate who are way better than that than me, but it's a super interesting one thinking about how LLMs are going to read documentation, do all this kind of stuff. If we can maybe also come into sort of just like client server design around like the processing in these LLM programs. I'm really curious about one, like if you have sort of like one project I've been doing is like question to blog posts where you have this kind of flow of like first you take the question and generate an outline, then you split the outline into the topics, and then you parallelize that to flesh out the paragraphs. So you have this kind of like parallelization design that I imagine like is each like a microservice, and they each maybe have like this design, and I see this as being kind of related to client server kind of thinking. Yes, what do you think about that kind of like taking each part of the LLM system and then making it its own API, and then how you orchestrate that?
Yeah, yeah, that's interesting. Um, I mean, my first thought, based on sort of what you're describing, is that each of these concrete steps can almost be like an agent, right? Like each of these, um, if you have like this process, you sort of define each step in the process and um, make like a purpose-built thing to accomplish that. And so, if there's some way for you to sort of have this API surface that's growing along with the different agents that you make available, maybe um, there's some way to sort of have like this um, system where you're building, you have like a nice way of defining what agents are available in your system, sort of like in your open API spec or something, um, and expose those agents and sort of what you can do with them to accomplish these like common like research or blog related tasks in a nice API.
Amazing. Yeah, yeah. So I have so many ideas on this. I guess like the question I really want to ask you, like with our brainstorm and talking about like Redis, I'm very curious about sort of the role of caching and disk and this kind of thing with with these kind of compound LLM systems. Because as we were kind of talking about RAG, we both mean like sometimes we just mean question answering, but mostly we're kind of evolving into these compound AI systems, like the blog writing example where there's like several parts of this, and so you might want to have like this cache, like if you have a session ID, because you have a session ID for this request, and it's like following all these steps. As we earlier at the very beginning, we talked about like 5 minutes of processing, and I think very much that's the future. I think we're going to see like leaving it overnight, and we can open that one later. But I'm very curious about like with Weaviate and and understanding if this is something that we should build and we should be thinking more about is kind of the role of caching in RAG. And I think there's kind of two things. There's like caching this intermediate state as you're processing like writing a blog post. And there's also maybe caching like frequently accessed documents in RAG, because I don't think you really, sometimes you probably could just search in a cache of like 1,000 documents, and that would probably get it done.
Yeah, I think there's definitely a lot of interesting stuff there. Um, I mean, I think caching is obviously going to play a big role when you have those like response times that you need to be like really tight and fast. If you're having if a delay of 5 minutes is okay, or like you're letting it run overnight, which is totally fine for some situations, then it's less important. I think one really interesting development I had seen was with quantized RAG, where you can explain that briefly. Quantization is where you basically like take your embedding. So you have a list of like 1,000 plus 32-bit floating point numbers, right? And you can quantize them. And one approach is to use binary quantization. And so
Mm-hmm.
then you threshold all of those floating point values at zero. So if it's less than or equal to zero, you set it to zero. If it's greater than zero, you set it to one. And so now all of these 32-bit floating point numbers can be represented in a single bit. Um, and you don't, when you do this and then perform your traditional like vector similarity search and stuff, um, you don't actually lose that much performance. There's a recent blog post on Hugging Face about it, where this binary quantization, you still maintain about 96% of the output quality, and you're throwing away like 31 bits of information for every single um, floating point number. So once you do this, then you're a lot more easily able to take like I think what's the math? If you take a terabyte and you quantize it like this, then you get down to like 32 gigabytes or something. You could put all of that in memory and have this like massive data set that you do like these very fast queries on. And I know Weaviate supports this binary quantization and some other forms right out of the box, and like lets you make these like really fast optimized queries like that.
Mm-hmm. This is a big one. I think it's definitely a big development. I think we got this from DiskANN, where DiskANN had this idea of you're traversing the Vimana graph with the compressed vectors, and then you'll bring the full precision vectors back into memory to resort the list periodically. And now there's a lot of discussion around like searching with binary vectors and rescoring not only with float 32, but now they want rescoring with int8. And then there's a lot of pressure on like providers like Cohere want Weaviate to natively ingest like bits and bytes instead of float 32 vectors. And maybe I can talk a little bit about this. It's not like John, Eddie, and Abdel at Weaviate would be like, this is definitely a big topic, but like I do think the question here is, so we quantize data, Weaviate with your data distribution with the k-means, and we're using your data distribution to quantize it and do the centroids. Or so that's one way of thinking about what will be the best way to quantize in the future. Or the other is the model providers, they quantize as they train, and then they use like straight through estimator to have that, to get through the discrete bottleneck and the gradients. And I don't know how that's going to play out, honestly, but I do think yeah, it's definitely interesting. Like there are a lot of low level optimizations that go into Weaviate. Maybe people will be listening will be interested in our new blog post with Intel that talks, there's like it shows the assembly code that Asdean and John have been working on, and you can see like how low level it can get. with this kind of topic, and I'm not much of an expert on it, so I'm kind of walking into territory I don't know too much about, but which would I think be a great transition to our next topic I don't know too much about, which is is diving further into clients written in Python versus clients written in Golang or Rust. We saw, LangChain Golang Go is one of these libraries, and like for me, I've had to learn Golang for Weaviate. I only did Python in my PhD, so like I didn't know too much about it. But now that I see with Golang, and I like Python. Like you have Pydantic typing, and so there is a lot to like about it. But and I'm still kind of learning it. I like Golang. I like the interface for Go routines, and like waiting and locking is really, and like mutex is I like that maybe more so than Python. But yeah, if we could dive into this topic, yeah.
Yeah, that's something I've been really interested in. Is like right now it sort of seems very standard practice to like build all of these pipelines and stuff in Python using something like LangChain. And Python is great for like fast development and certain things, but I think there are a lot of places in these systems where you can drop down to a lower level language like Go or Rust or something and see big performance improvements. So when I was just messing around, for example, I was benchmarking, doing like text splitting on like a couple 100-page book, and just like with a very naive, um, the naive LangChain text splitter, it takes about 200 milliseconds. And then I made a very similar implementation in Rust, and it takes like 2 milliseconds. And it's still giving you the exact same information. So like which parts of the system are there that you can optimize? I think the sort of prevailing wisdom says that you'll get about an 80x improvement in speed when you switch from sort of this interpreted Python to something in a lower level language that's compiling directly down to machine code type stuff. And so that's going to be the difference between like processing a terabyte of data per second versus 12 and a half gigabytes per second, right? It's like massive in certain areas. I don't think it obviously doesn't apply to every part of the system. Like when the LLM is the limiting factor and you're waiting on responses and stuff, like there it probably doesn't matter as much. And then in other places, like you can, it might already be heavily optimized in Python and calling out to a lower level language already, and you just don't realize that. So it's definitely not like a silver bullet to convert everything to these low level languages, but I think there is probably a fair bit of opportunity to take different parts of the pipeline and optimize it, and like figuring out where those are, I think would be huge.
Yeah, I really like the chunking example. That's definitely a really good one. And it's kind of comes back earlier to ingestion, talk about like the distributed messaging queues, whether that should be in Python or Golang. I think it's maybe worth like kind of like the models themselves tend to be compiled though with things like TensorRT, right? And so it's not like the model inference is uncompiled generally. And I think maybe that would be something that like my first like curiosity was like, oh, what if we ran the models in Golang? But I do yeah.
Yeah, I think like all the models and like inference and like all of that stuff is super heavily optimized because this is like billions of dollars are like going into like building these models and like running these pipelines. So um, they're like down in the GPU code and stuff. They're way
Oh
more
yeah.
optimized than even like uh, Go or Rust or anything.
Yeah, that was sort of my one of my experiences from NeurIPS this year was I met a couple people who work on like JAX compilers, and it took me like 2 seconds to just be like, "You're smarter than me. I'm not capable of holding this conversation." But yeah, it's a super interesting one, and more power to you if you're compiling machine learning models and stuff like that. Awesome. So, anchoring topic I really want to talk about is, and I know we're pivoting a bit here, is prompt optimization. We've mentioned DSPy a few times, and I think also there's kind of like there's been a lot of like Anthropic is they have been putting out some stuff about how well their model can write prompts for you. And yeah, so I'd love to just get your thoughts on how you think about prompt optimization.
Yeah, I think prompt optimization is like a big thing that you can use LLMs to help you do better at. Like if you just like give them some examples and like let them automatically optimize your prompt, you're going to end up with something that's a lot better than uh, if you spent like an hour handcrafting something. It's not necessarily going to be as good. So these tools like DSPy that we're seeing come out, and like this automatic prompt generation idea, I think LLMs are actually like a really great tool for that. Like that's I mean, they accept prompts. They must know prompts pretty well, right?
yeah. Yeah, I think, and then there's layers to this. There's like, which is the best model at prompting other models?
Yeah.
And it looks like maybe Anthropic has, like, maybe they've been training their model to do this already, and they're already kind of thinking along this direction. I guess like there's a couple things. There are two questions really I want to get your take on. The first of which is DSPy's CoPro optimizer that I'm really fascinated with. So CoPro and MIPRO are two of the newer optimizers in DSPy. MIPRO has kind of a lot of things going on. It has this like, inspect the data set, reflect on the data set, use this in the prompt, as well as this kind of like Bayesian optimization of candidate instructions and few shot examples. But CoPro is maybe, a quicker one. It's kind of uses like evolutionary algorithm where you have like one prompt and then the resulting metric, like the performance, and then another prompt and the resulting performance. And then it's kind of like this new like LLM crossover step. We saw like in Prompt Breeder from DeepMind where, yeah, so it's taking these prompts and their performance and it's using that to write a new prompt. And yeah, I'm just so curious about like this new take on evolutionary optimization with LLMs.
Yeah, I really like that, and I think like it's also really helpful if you have like specific needs in your prompt or you're trying to accomplish something really specific. Being able to have this sort of process and like clear metrics that it can optimize like makes it um, a lot more like reliable to like keep generating these prompts that you need for the different pieces of your system. Um, I know I've seen like DSPy's like auto like chain of thought prompting stuff, and like that's just amazing. Like trying to write a good chain of thought prompt and like do it on your own is super annoying. But like being able to just like plug it into DSPy saves so much time and gets you like better results through these optimizations than you would be able to by hand.
Yeah, that was one of my quickest like, oh, I love this DSPy thing is seeing it right and I guess it's so fascinating even this kind of like now my current way of thinking about this is like you would only kind of need to tweak the instruction if you're tuning the prompt for GPT-4, Cloud Opus or like Gemini Pro 1.5, but if you're doing like, Llama 2s or maybe even probably still with like well like do is command R llama 270b the new DBRX model from Mosaic, is that's like somewhere in the middle of this, but like there's this scale of whether you need to instruction tune or just few shot example tune, and this kind of like few shot example sourcing by just running a high capacity model through the program with the let's think step by step, and then that's how you got your examples instead of you having to write the rationale. But this actually transitions us really nicely to the other kind of prompt optimization question I wanted to ask you about, which is self-discover. And so self-discover, it can be, I interpreted it a few ways. Like on one hand, it can be, searching for the building. I think like the original paper is more so targeted at like, does your task need chain of thought or does it need, let's think out of the box or, let's think symbolically and come up, and think with math and stuff like that. So maybe on that first level, there's just the search for these kind of like meta prompts that you kind of put in your prompts, and then there's also like the more open-ended like if you have a task like your task is to write a blog post, please decompose this into subtasks. The LLMs can also kind of like write the program for you. Yeah.
Yeah. Um, yeah, I think this sort of prompt optimization and like figuring out like which task you even need to be performing for um, some prompt is like a fascinating question. Um, it almost seems similar to we were talking about earlier with like the routing
Mm.
piece of information or routing a prompt or something. It's like this seems really similar where you're sort of routing it to a bunch of different techniques that you know about for accomplishing a task. So like maybe even this is just like a layer in there somehow,
Hmm.
where like it can identify based on your prompt, like this kind of prompt is really, it's really important to have chain of thought in this one. It's important to think outside of the box or whatever that is. Maybe that's sort of like the layer where this like fits into the system really nicely.
Amazing. It's so like meta. I love the like AI designing AI. And I love how you kind of like say, okay, let's try think out of the box, and then you do the few shot example compiling to make it like more specific to your particular like tax rag kind of thing. And then as well as the program, kind of like we design this program, then we compile it and test it, and it's like inner outer loop kind of like meta gradients that sort of like mammal thinking returns. And yeah, I love all that. Awesome, Kyle. So an anchoring question: what future directions for AI excite you the most?
Future direction. So like I'm a big fan of sort of the agentic approaches and stuff, and like building this like big network of agents that have uh, particular tasks that they're just like really excellent about. Like one of the things that really excites me about that is it's a lot more approachable of a problem where it seems like you can just sort of go and make something that's like really good at a specific task, and like how
Mm.
can you like expose that to other people. It's something that you feel like you can really individually contribute to. So I'd love to see sort of like these agents come together and like have a network of
Mm.
sort of tools that AI can use and sort of uh, do build like this network that can do increasingly more tasks as like more specific agents get added to it. I think that's like a really fascinating concept that uh, I'd really like to see how that's evolving over time.
Yeah, amazing, Kyle. This conversation has really helped my understanding of yeah, the function calling and agent design, that kind of thing. Particularly, I really think we just definitely for my for my understanding, and hopefully for our listeners as well. Kyle, this is such a fun exploration of RAG and all these topics. I really hope our listeners check out RAGKit and all these cool APIs you can use to build RAG systems. Kyle, thank you so much for joining the podcast.
Yeah, thanks for having me, Connor. It was great.